Right, volumes now. Volumes is um, the amount of space or the amount of material within a certain three-dimensional shape. So let's have a look how we calculate volumes. So cubes and cuboids will be the first one, and then we'll move on to different shapes, more complicated shapes. So imagine that this is a cube. Now a cube, um, all 3 centimeters. Now in a cube, all sides are the same, as we already know. All sides are the same. So to work out the volume, it is equal to the width times the depth, or could be length, I suppose, times the height. So there are 3 things to multiply together. Um, so if that's 3, then that we'll call that the depth, or length, doesn't matter. Or is depth the opposite of height? Oh gosh, yeah. Um, yeah, if you've got a swimming pool, it's depth, isn't it? The depth of the water would be the same as the height of the side wall. Yeah, okay. So it's all a bit, English gets a bit complicated. Width, length, breadth, depth, height. Oh, let's just do the maths. Don't worry about all the English. So we've got 3 over there, three high, and 3 there. So that whichever words you're going to use, it's going to be 3 times 3 times 3, which is 27. And of course, it's going to be centimeters, but this time we're going to put a little 3 there, yeah? And this means cubed, yeah? Now, volume is always in cubed regardless of the shape. It has nothing to do with that's a cube. Yeah, it's always cubed. Like a circle can be 10 centimeters square. Yeah. So this 1, 2, 3 things multiplied together to equal the volume. And the volume is 27 centimeters cubed, which means that we can fit in there 27 tiny little cubic centimeters, yeah, 3 wide, 3 high, 3 deep, yeah, that sort of thing. And sometimes you get volume questions where, this might be the back of someone's van, yeah, and yet they open the back, and the back is this volume, and you've got to work out how many little boxes go in the back of the van. And yeah, so it's like tiles on the wall or bricks in the wall is the square equivalent to this volume calculation. So how many boxes you can get in the van. I'm sure that lorry would be a bit bigger than that, but there, that's by the by. It must be a toy lorry. Okay, right. Now let's do cuboids. It's very easy, this, cuboids. Now a cuboid is just the same as a cube, but it's sort of stretched. Yeah, a cuboid. And we'll call that 4 meters, 2 meters, and 10 meters. Yeah, so you've got the width, you've got the height, you've got the length, and so it's going to be 4 times 2 times 10, which is 880. 80 meters cubed. 80 meters cubed. Now, see these two here, the 4 and the 2. If you multiply that together, the 4 times the 2, that will equal 8 meters square, which happens to be the area of, I'll call it the front, yeah? And we're going to remember this when we work out different shapes. But for the moment, cubes and cuboids, if you can find the 3 dimensions, you just multiply them together. It's as simple as that. Now, the only thing that they can catch you out on is if you have your lovely cuboid here and you've got this is 8 meters, 3 meters and 200 centimeters. This, you cannot multiply these 3 numbers, so you must make all the units the same. Now, in the question here, we've got to have 2 choices here, is what's the volume of this shape in meters cubed or in centimeters cubed. Now, this tells you which way to change the units. So, first of all, we're going to do it in meters cubed. And it might be that you get an answer line down here, tick, 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 and they might actually have meters cubed written on there. So look at that first to see which way you need to convert. So I'm going to do it in meters cubed, and so I need to convert this to meters. So 200 centimeters, I need to divide by 100, which equals 2 meters. So now I've got 3 times 2 times 8, which is 6. 6 eighths are 48 meters cubed. Now, vice versa, if we wanted the answer in, remember that was 48, yeah, meters cubed. If I wanted it in centimeters cubed, I'd have to change everything to centimeters by going 3 meters times 100 equals 300 centimeters, and 8 meters times 100 equals 800 centimeters. So now I've got 200 times 300 times 800, which is 2 times 3 is 6 times 8 is, again it's 48, but I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All I did was multiply the numbers together and added the right number of noughts, 6 noughts, and that will be centimeters cubed. So you see that's 48 million centimeters cubed. So you can see that I get the 48, it's the same no matter which way round you do it, but you've got to make sure that you make all the units the same and read the question carefully, and it will give you a clue about which way to do them. Okay, let's have a look at some examples. Here we go. Oh, we've got millimeters and things. Calculate the volume of the shapes below. So these are all in centimeters. It doesn't tell you what the answers are, so everything's going to be in these. So this is just going to be 30 times 30 times 10, which equals 3 threes are 6 times 6, 6, 1, 2, 3. 9,900. 3 threes are actually 9, aren't they? Oh, they are indeed. So is that, just double check now that I've times 30 times 10 equals 9,000 centimeters cubed. And this one's going to be 35 times 50 times 40. Because it's multiplied, it doesn't really matter which order you do it in at the moment. 35 times 50 times 40, using the calculator to save embarrassment. 7, 0, 1, 2, 3, and also my brain power. Yeah, so they're nice and easy, aren't they? Can't see how that will be a level 2, but anyway. So right, Sarah has a suitcase that is 1.2 meters long, 0.7 meters wide, and 20 centimeters deep. Okay, so we've got a mixture. So what's the volume of the suitcase? So I'm going to change everything into meters. Yeah, so I'm going to make my answers to meters cubed because it doesn't ask me either way. So all I need to do here is I need to change that to meters by dividing by 100, which equals 0.2. So I've got 1.2 times 0.7 times 0.2. 1.2 times 0. Hang on. 1.2 times 0.7 times 0.2 is going to be 0.168 meters cubed. Now, if I did change them the other way around and make them all centimeters, multiply these numbers by 100, so I'd get 120 times 70 times 20. So 120 times 70 times 20, which equals, no surprises, you get the same 168, and this time I've got 3 zeros on the end to make it centimeters cubed. Right, let's have a look. This looks more complicated. George is buying a gravel pit to put in his driveway. The driveway is shown below, so we're looking down. So we've got a plan elevation here. Looking down, he needs the gravel to be 2 centimeters deep, and he can buy the gravel in bags that cover 1,000,000 centimeters. Yeah? Cubed. How many bags will he need to buy? So, because I need to work out the volume of the driveway and compare it to how many million centimeters cubes I need, which means how many bags do I need my answer for the volume to be in centimeters cubed. So I need to change this into centimeters cubed. So 12.2 times 100, which is 1220, and 3 times 100, which equals 300. And my other one there is 2 centimeters, so I don't need to change that. Yeah, so this is already in centimeters, this is already in centimeters, so let's multiply the 3 together. So I've got 1220 times 300 times 2, that's the depth. See what that comes out. 1220 times 300 times 2 equals 732,000 centimeters cubed. 732,000 centimeters cubed. Bags cover 1,000,000 centimeter cubed, so only needs 1 bag. Right, now I don't know how heavy 1,000,000 centimeters cubed might be. It's 1,000 kilograms, might be 1,000 kilograms, a ton. Oof, but we don't need to work that out, yeah? So there you go. So that's volumes with cubes and cuboids. If you get lost, you can always watch it again. Watch it double speed if you get bored. And worksheet coming up, I suppose, for these slot. And I'll see you in the next one.